Thanks, everyone. And thank you for your time joining today's ESIP, Semantic Tech Committee webinar. Good morning, good afternoon, or even good evening to all of you. And today we have Dr. John Erickson from Rensselaer Polytechnic Institute, aka RPI, to give us a talk. Yeah, I will do a very short introduction to John, and then we give the floor to John for his talk. I collaborated with John at RPI because I spent about 4.5 years at RPI between 2012 and 2016 when I was a postdoc. It's a very pleasant experience. John is such a nice person. And currently, John is the Director of Research Operations at RPI's Institute for Data Exploration and Applications, the IDEA Institute. And he's also the Deputy Director of the Web Science Research Center at RPI. He coordinates, contributes, and teaches a lot of those informatics and web science related topics at RPI. And today he's going to talk about his colleagues' recent research on large language models and knowledge graphs. Okay, John, I'll give the floor to you.
Okay, well, the first thing I want to know is I want to call out is I'm scanning the names on here, and there's a couple people that I actually know. Gary, we haven't seen each other for 100 years. I know Gary Bird-Cross. And some of the other names I think I recognize. But anyways, hi to all of you. And I should say we've got a few of my, both my co-authors on the Journal of Web Science paper, as well as 2 students who are currently working with us on an implementation of this thing we call ChatBS NextGen. And I'm gonna share right now, and give me everything. So hopefully you see. Do you see?
Yep, the screen is up.
My stuff right now, and okay. And I should say that I can't see you right now, but if you have a question, please just shout it out. That's okay. Don't text it. I won't see it. Or maybe Marshall could, or Waylon could be watching to see if there's a question, and feel free to interrupt me. So the title of this talk is the title of our Journal of Web Science paper. This is, I believe, in the current issue, which is focusing on a Journal of Web Semantics paper, talking about knowledge graphs. So the issue is concerning application of knowledge graphs in general. And what I'm going to do is kind of tell this story. It's been this evolving story of us sort of bullshit checking LLMs, and this is the kind of the cover sheet for our Journal of Web Semantics paper. But this story starts with this application that we created in early 2023 called ChatBS, which is kind of a challenge by a couple of my bosses, whom Marshall knows well, Jim Hendler and Deborah McGinnis, to create sort of a unique application that could be a LLM, large language model API client that would kind of facilitate experimentation, but would also try to find a way to use what we're really good at, things like knowledge graphs for fact checking. And so so I'll tell the story of ChatBS first, and how it evolved, and how it evolved way beyond its initial objectives. Then I'll address this experiment, this use case that we describe, and this proposed architecture that we describe in our Journal of Web Science web semantics paper, which is really how do we create a platform that facilitates a particular kind of experimentation and result validation based on this work that we had done with and this learning from ChatBS. And then I'm going to cover some work that's going on right now with a couple of our students, which we call ChatBS Next Gen. And it may be a little bit confusing. We refer to ChatBS Next Gen as an architecture in the paper that we wrote, but we also refer to it as this platform that we're building. And hopefully it'll become clear. But so this is the world's busiest slide. But what this is meant to show is this is kind of a very recent screenshot of this ever evolving thing that we call ChatBS, which started off being we refer to it as a fact checker, but it quickly became much more than a fact checker. We built it up as a very, very flexible tool for experimentation. First with the OpenAI models, LLM models, but then other models. And you can see on this left-hand side, we have the ability not only to select a different model, but multiple models. But we can kind of see this is a kind of a generic view of it. You may be familiar that with large language models, there are two prompts that you provide for it. There's a system prompt and there is a user prompt, and sort of this default question. I should also say that the focus with ChatBS was on a particular use of large language models, which is question answering, which is a lot of what it gets used for. So we had noticed when ChatGPT first came out, late 2022, early 2023, the particular model that it was using, the version of the OpenAI model was GPT-3.5. It was making a lot of errors, and it's sometimes very humorous errors. So we wanted to create a way to exercise that, and so this is kind of our default question was, what's the oldest technical university in the United States? Which is, of course, RPI. But it was fascinating with GPT-3.5, the variation of results. But we noticed that, with these, because these are non-deterministic models, these are, probabilistic with the way they provide, how do you experiment with such a thing? You don't do one try. You do multiple resubmissions. To really get a result, you've got to hit it multiple times. So over time, we added the ability to add multiple resubmissions. As new models began to be introduced, and now I'm kind of scrolling through time here, we had the ability not just to select different models, but also to select multiple models so that you could test, you could compare like results. In this case, we've got Llama 3 shown, but you could have the various different GPT-4 versions, 0613 or Turbo or whatever, these different models, and you could compare them. We had, in the literature, we had seen work on whether or not these large language models could actually reason or emulate reasoning in different ways. And one of the more popular ways to do that is to extend your prompt by asking it to explain step by step, which is called leads to what's called chain of thought reasoning, which is a form of completion that looks like it's reasoning by step by step by step. And since this is a common thing to play with, we have this ability to kind of extend your prompt just by checking it. And some other work we were doing 2 years ago, we were looking at its ability to correctly reference, reference meaning provide citations for facts that we were asking for from the literature. We wanted to actually measure its ability to do such a thing. So we clicked on it. We had a box that extended its prompt with include references, and it would make an effort to include a citation, which was, even with GPT-4, one of the better models. It was pretty humorous. Over on the right-hand side, you see some of how results were presented. You see, this is kind of a typical response here. I know it's difficult to read, but it basically gives a this is Llama 3.1. It gives the correct answer, and kind of by default with Llama 3, it kind of explains that it was, when it was founded and why it was founded, that sort of thing, and you can extend it. With these, by being able to ask it automatically for up to 10 resubmissions, it was really fascinating for us to see how a model like GPT-4, any of the GPT-4s, could come back with like 10 different correct answers, and each of those 10 answers was different. Early on in the life of ChatBS, because we're part of us is the Semantic Web group, we were thinking, how can we use what we know to fact check. And one of the ways that we conceived of was to have the option, here it's enabled, to create a graph, and do entity resolution based on the answer. To take the answer and discern the relationships, the subject, predicate, object relationships in the result, and make an effort at entity resolution based on some graph, which we used at Wikidata. It's amazing that we were able to do this. One of the authors, Jamie McCusker, built what we call the back end, which would essentially use an LLM, starting with GPT-3.5, but eventually GPT-4, one of the GPT-4s, to extract the relationships, and then use those, then take those relationships that were asserted and attempt to do entity linking, both for the subject, predicate, and the object, to some in the case of relationship to ontology, in the case of the subject and predicate to like Wikidata, which was fascinating. Where and just as an aside here, you see that there's one of these that's highlighted. This is a funny thing that it did. If you know Semantic Web, linked data, one of the things you can have is a B node. Sometimes the relationship that was detected is sort of it's a thing. It's a conceptual thing, but it's for real, but it's actually not in, and it's not found in Wikidata. So it's like if you can imagine synthesizing a label for a B node, or an entity name for the B node. That's one of the things that came out of it. So this in itself was pretty fascinating. But what I mean to do here is just kind of give you the lay of land. This is, when I refer to ChatBS, I'm referring to this experimental client that it's all manual. It's all about manually setting your system prompt, your user prompt. This is setting up these settings. Most of the time, we actually don't use this RDF, this relationship detection RDF finding, because most of the results that we're interested in are much wordier than this, and it's kind of impractical. But I show these. This is essentially the same slide as I showed before, but with without all my callouts here. You can see it a little bit more clearly. Some other examples here. I just in passing to kind of show you the kind of experimentation that we did with ChatBS. Here we're asking a question. It's the same question as before. We've clicked on Ask LLM to explain step by step, so it's tacking on this onto the prompt, the user prompt that gets submitted, and we see I've kind of prettified the result that's provided by the Llama model, and you can see here what, and this is the actual result, and this is chain of thought. This is classic chain of thought. It's going through and it's kind of listing these technical universities. It's establishing the dates that they were founded, and then it's somehow suggesting that RPI is the oldest. And given the fact that they actually can't reason, it's doing it by it's doing it by its LLM transformer magic. It's not actually doing any sort of reasoning. It's not referencing any sort of actual knowledge graph. This is pretty fascinating. And if I had asked for 2 results, if I asked for 1 result again, if I asked for 10 results, it's going to come back with not only different supportive facts, it'll even have a different structure for the chain of thought, because I am not specifying in these examples how I want them structured. And notice that I have the RDF generation turned off. Okay, this is another example showing just again illustrating this point about the different results. All of these answers are correct. All 5 results have RPI as the oldest technical university. Some of them start off very similar explanations, but each one is different, and they go down different paths. Some of them include references to Stephen Van Rensselaer, the founder of RPI. Some of them go into why, and they have no knowledge of each other. These are each independently submitted to the API. But part of the reason that I'm showing this is it emphasizes that when you experiment with an LLM, you can't have an N of 1. This is a probabilistic thing that's coming back. When you ask for a result, when you're asking a question, you can't ask it once. In order to make, if you're doing any sort of quantitative sort of analysis of what's coming back, you have to have a framework for submitting multiple times in order to make any sort of evaluation. Okay, so this is just a kind of an architectural sketch of what ChatBS is, and it's kind of an older diagram. You see the title of the slide is still referring to the fact checker. We tried to get away from that name, but you can kind of see here it's there's. And by the way, I should have put in a word for it. ChatBS is completely built on R. It's a Shiny app. If you're familiar with R and building web apps based on R, it uses Shiny, and it is publicly available. It's been publicly available almost from the start, and it uses both. It hits both the OpenAI API, and it hits also our Llama is actually an internal Llama that we've been running on a virtual server. But you see it hits the continuation API and OpenAI. The responses come back. If we're doing RDF generation, we've got this backend service which is built on Python that both determines relationships and tries to look up the entities in Wikidata and comes back, and you get a graph. And 2 years ago, our thought was maybe we could use that graph that it produced as a way to do fact checking, comparing the result graph against an authoritative knowledge graph. And that's kind of a challenge, but we ended up coming up with a different way to do it, which we'll get to. Okay, switching gears here, this paper that we wrote. So we wanted to write about our experiences with ChatBS, but we wanted to talk about more. We wanted to kind of look ahead and think, well, what do we desire for actually doing the kind of experimentation that we're doing, that we aim to do? And what have we learned from our manual testing with ChatBS? One of the things is you want this ability to specify what we call prompt strategies, these different kinds of prompts. Essentially, are we doing a single shot or few shot? Are we doing a chain of thought? Are we doing some other kinds of prompts? We want this ability to not just specify the prompts, but we want to do, for experimental purposes, we probably have a set of data that we want to submit. So we want this ability to easily specify templates for those prompts, and with placeholders, essentially with variables in those prompts, and to be able to fill in those, but have the LLM do it. I mean, that's one of the things we have the ability to do, but or have the system do it. But anyways, this idea of here's my template, whether it's system or user, and here's my data set with my variables, and submit it, and have it automatically do whatever I'm asking it to do in terms of repeats. I want to be able to supply that data easily. I want to do things like specify how many times I want it resubmitted. So think of this as if my n, if one dimension is the number of observations in my input data set, then I also want to be able to specify the number of resubmissions across that. So if I'm submitting say a patient information for a nutrition use case, which I'm coming up to, maybe I actually want to resubmit that particular patient 10 times with the same settings. Okay, I want to have a hook in there that allows me to process those results. I want this ability to specify what my evaluation is. What in that result that I'm getting back from the LLM do I want to actually pull out and check against some authoritative graph? In the use case I'm going to talk about, it's a graph called Food KG, but it could be, as we discussed before the call started, it could be some earth sciences data set. It could be something else. And since we're semantic web people, we're always, of course, thinking graphs that you hit with Sparkle. And the possibility of having sort of Sparkle query templates where we're filling in the blanks. And then, of course, it's not an experiment if you're not collecting all the conditions and trying to make it. And I caution with the word of, I put in reproducible, but that's mostly so I could emphasize the fact that really what we're talking about is repeating the experiment. Because this is a non-deterministic thing, you're not going to get you're not going to get identical results coming from large language models. It's almost like dealing with a physical system, but you ought to be able to repeat the conditions and get similar statistical results. And that's kind of the important thing, that this is not about getting identical answers back. This is about reproducing the conditions that you submit, and the number of repeats, the number of retries, the models that you use, the versions of the models that you use, and getting and reconstructing a data set in the same way. This should give you comparable results. Okay, this is what we call the proposed architecture in the paper, and this is also what our students, Nippon and Devin, are currently working to implement. Now, so in the paper, what we did was we pretended that this architecture existed. And so we constrained ourselves to conducting the experiment manually, as if we had a system that was constructed in this way available to us, but we did it using ChatBS. So we submitted hundreds and hundreds of artisanally crafted prompts to ChatBS in order to produce the data set, but to replicate the kind of flow that you see here. And you see that there, some of the key things I talked about before. We want, selecting the prompt strategy, and that would include the models, the templates for system and user prompt, selecting data sets, either CSV files or JSON files that you can read in and fill in those prompts. Under the cover, that's going to this is all going to be managed, and it's going to come up with these prompt instances, which you could, if you wanted to, just type in by hand. It comes up with these instances of the prompt, which is then sent off to whatever model you happen to is appropriate for that particular instance of the prompt being sent off. So if you've got a particular prompt that you need to send it to both GPT-4 and Llama, it's going to manage that. And thankfully, there's these Swiss Army knife packages now in R. There's a new one called Elmer, which makes interacting with these in a very uniform way. The other thing is really nice in terms of experimenting with LLMs is they've kind of most of the providers have adopted the interface that OpenAI used for their API is kind of a standard. So it becomes pretty easy that there's a uniform expectation of how you exercise these LLMs, which is really nice. And then you get your responses back, and then we crunch it in different ways. And this is a little bit of wishful thinking based on what we currently have, but what we do have the ability to do right now in our prototype of the next-gen platform is that response comes back. We have the ability to template what it is that we're looking for in the result, and then we have the ability to query the knowledge graph and compare those values that we extract from the LLM results against the KG values, to validate the responses. So if you've in our case, in this use case I'm going to describe, we were ultimately looking up foods, looking for their glycemic index and checking whether or not where they were with respect to a healthy threshold, healthy or unhealthy threshold. with the challenge that the question that had been asked of the LLM was, give me a healthy recipe recommendation. And if I'm a diabetic and I'm getting a recipe that's got high glycemic index values in it, that's unhealthy. So that's a fail. So that was that. But you can, insert your knowledge graph here, insert the kind of question you want. That's the kind of thing that we were trying to go for. So it's really important when looking at this architecture, this is about validating answers. This is not about using a graph in the upfront in the training part. This is about BS checking the actual results that are coming back, and then documenting those. Okay, and so I've kind of already described what we were doing, but we had this data set that I'm sorry, I gotta close my door here. I got two dogs that were acting up. So we've got this data set that's descriptions of kind of the health conditions of 100 patients, and the idea is that we're going to ask the different LLMs for dietary recommendations, or we're gonna have these templated prompts. We're going to fill in the patient data, and included in that data is whether is their health condition, like are they diabetic or not. And the results are going to come back from the LLM, and then we're going to parse those responses, and we're going to parse those responses and then check them against this knowledge graph called Food KG. Food KG was done a few years ago as an output of this big HEALS project that RPI did with IBM. And HEALS is a HEALS, the Food KG is a publicly available knowledge graph. Okay, and I apologize. This is might be a little fuzzy. These are actually screenshots from the Journal Web Science paper, but you can kind of see this is describing how we set it up. It's kind of the prompt strategy is going to be a chain of thought. We're going to test it using GPT-4o Mini and Llama 3. The number of resubmissions is depending upon what we're doing. It's either going to be 1 or it's going to be 10 if we're focusing on a particular patient. You want to be able to provide the URL to the endpoint for the knowledge graph. This is the system prompt. Okay, so the template, the way we constructed it, the system prompt is this is where we're actually providing the slots for filling in the specifics about the page, the patient. So we're actually going to give this as part of what we send off to LLM. It's got bracket name, bracket age, bracket gender, bracket diagnosis. That would be if they're diabetic or healthy, height, weight, body mass index. All of these are really important, and even food preferences, like I'm a vegan, okay, and any allergies. This is so when you look at this, you got to imagine that our ultimate goal is in our app, we're actually going to have places, parts of the UI where we specify this or read this stuff in. The user prompt is actually pretty lightweight. The user prompt is just, I need suggestions for light and energy boosting foods to eat before my gym workout. Okay. And then you're going to give it a data file, which in the test case was a CSV. The CSV has columns for like name, age, whatever. It's going to read in those 100 patients' information. And then, so what actually ends up going off is it's going to look like this. This patient 98, anonymous 98 is the name assigned to them. This is the template being filled in with the values that come out of the CSV. So this is like one example of it going off. And if I asked for 2 models being selected, both, this prompt would be sent off to both models and we get different responses. And so part of the job of the framework is to keep track of all of this stuff. So everything you see here, ultimately we want to have downloadable in a JSON file so we can chomp it up and do our analysis on it. This is an example of that result, of the result coming back. This is being used. This is Llama 3 again. This is an example of a result coming back for that anonymous 98. And you see that it kind of breaks it down and different dietary things. And one of the things that I've got highlighted here, you see there's honey or maple syrup. These are highlighted because these are, we're going to come, when we do our analysis, we're going to see that those are gotchas because the patient's diabetic and we're seeing that that's there. But our goal is, our system should automatically be able to pick up that this is BS. This is a bad recommendation for a diabetic patient because both of those, we just kind of know from experience, are high on their glycemic index. Okay, so here we are. This is for those of you who do KGs, this is a fundamental problem. We run around all the time. We go to conferences now where we talk about, knowledge graphs are going to save the world. Knowledge graphs are awesome. Knowledge graphs are authoritative. Well, they don't do a very good job if they're empty for everything you need to look for. Okay, and this food KG is a pretty good knowledge graph. And in the course of this work, I compared the data in it against other sources of other indices. There's a great one from Australia. There's a couple other around the world. Are there other data sources that are more complete? And like, no. And in fact, I suspect that I found some of the sources online that the people who our students who put together Food KG did. I was not directly involved in building Food KG, but I was on the periphery. I knew the people involved, but you can see here the food recommended. These are all foods that were recommended by either of the 2 models. Okay, and on the food KG ingredient name, these are the kind of a confirmation of what was found. So you see berry wasn't found, energy ball, granola, green. These are things that were pulled out as recommended foods. And then further, even if they were found, like coconut water or dried fruit, they don't have glycemic indices in the knowledge graph. Okay, so that's going to be a problem if what we want to do is evaluate the glycemic index. If we need to get the glycemic index of the recommendation coming back. So a problem is, does your knowledge graph or knowledge graphs or whatever your data sources actually have the data that you're sanity checking against? And so this is a problem. Okay, and if we want to stand up knowledge graphs to do this kind of stuff, they better be complete. And I can tell you, they're not going to be complete. So you better, as I told my students in a meeting earlier today, we've got to make it really robust for stuff that's missing. It's got to be. Okay, here's the stats. So this is actually this is kind of running down our results, both in general and for our test of actual healthy, whether the results coming back were healthy. The first part is, so we had 100 patients, and we're submitting that against 2 models. So we got a total of 200 responses just for that. And we can see that there were 483 foods that came back. But out of those 483 types of foods that were identified, only 178 or actually in the graph. So that's a problem. Now, if we subset that and say, let's only look at the 30 of the 100 patients, 30 of them were diabetic. Okay, so in that group, we got 260 foods were identified, and out of that, there was 123. So it's a better ratio, but we were just lucky there on that. But we see there's 47%. And so what were the kind of fails, what I call fails, this is my word. There were like a total of 10 foods that were, of those 123 foods, there were 10 foods that were had a GI that were above 50, which is kind of the threshold for high. This is bad, okay? And so we got that kind of summarized in this table down here. And Vladia made a really cool figure here that kind of, it's a graph that shows the way to interpret this is we've got our two models here, and what it says is there were Llama 3 recommended honey to 10 of the patients. 10 of the results had honey recommended. GPT-4o Mini recommended honey to 2 of them. GPT-4o Mini recommended pineapple to 9 of the patients. So this is kind of breaking it down to how bad and how bad, how sketchy, how borderline it was. But this is kind of this is getting to the heart of what we're trying to do. Okay, we want to ask questions in a structured way, parse those results, compare them against an authoritative source, and crunch the numbers. Okay, and so I've sort of alluded to these from a KG standpoint. We had some results. An issue with the KG we used was, and this is a KG that was created specifically to do these sorts of things, health related, dietary recommendation stuff. It's incomplete. Okay, when you've got the KG, there's an issue with a potential issue with incompleteness, and maybe the data that you work with is not going to be that problem. But I know Marshall and I did Deep Carbon Observatory. We worked with data from people all around the world, and there was missing pieces. Not going to call out any names, but there were some missing pieces. But another problem is in order for each KG is going to be differently structured. So there's got to be you've got to go into it template with Sparkle queries, sufficient Sparkle queries that are going to go after the kinds of questions that you are going to be, or the kind of data that you're going to be looking for. And I should say that this is what we're trying to reduce the problem down to one of extracting specific data items from the LLM results and making specific queries to the knowledge graph so that we can do the comparison. And there are semantic things that you could do that we really didn't get into, but there are semantic equivalences and stuff like that that could facilitate this sort of thing, obviously. But fundamentally, each KG is different. There are different ontologies being used. That there's going to be a challenge there. And this is a general problem. This is not just a problem for the type of thing people throwing around this notion of using KGs like magic. And KGs are awesome. They are by definition these authoritative knowledge sources. But we have to get to the bottom of that. And I'll just gloss over this. We found through our manual work that this is an effective architecture. Now, how do we make it so it's more automatic? So so what the students have been working on this term is actually building this out, building out a framework, prototyping to make this real. So Nippon and Devin have been hammering away on this, starting with this architecture that we described. Nippon came up with this beautiful, intuitive platform for validating large language models against authoritative knowledge graphs, effortlessly create text-based experimental pipelines, and automate the validation processes to ensure factual accuracy and reliability in responses. Amen. Amen, brother. That's what we want. Okay. So you can see this is an overview of how we would like it to work. Set up the pipeline, run the experiment, turn the crank, get your results back, do it in a way that's persistent, that uses the proper unique identifiers. It's beautiful JSON that we could number crunch on. Have the platform do as much as possible so we can do this little work. This is this is close to what their UI actually looks like right now. It's the current version, which I can't really demonstrate because they're kind of in a prototype stage. But you can kind of, what I wanted to kind of highlight here is kind of the thought process, what they're actually building. This idea that there are three big phases. So go back, there's set up the pipeline, run the experiment, view the results. So there's kind of three, if you imagine three big tabs. On those big tabs, it's sort of sectioned off. So this idea here that there's these different steps, and it would look very much like this. You're trying to avoid as much programming as possible. Is build the system prompt, build and kind of update it. And there's both this opportunity to do some manual munging stuff, maybe have some test data. I don't have drill downs into step 2, 3, and 4, but essentially this information extraction setup. This is amazing. This is what they've actually got working is I natural language describe what I want to be extracted from the LLM result, and then an R function is synthesized by LLM that will do that extraction, and then the code will use that function for the extraction at the extraction step later. Okay, the Sparkle query setup is a manual thing. Code generation is a little wobbly. It's pretty reliable for SQL, and it works pretty well for creating R-based like tidyverse data processing things. But Sparkle query generation from LLMs, we're not into that. And then the post processing is again what should we be comparing? What is the actual data to data comparison that we need? So that's that. Running it. Now, this is what's interesting is I might have different data sets that I want to submit to that pipeline. So it's an orthogonal thing. Here, I'm using the pipeline that I just created. I've got them stored away. I might specify the different models that I want to do this time. I'll load in my data. I'll tell the number of tries. So this is separate from my pipeline setup. So I could have essentially the same experiment, but slightly different pipelines. I can swap them. So it's separating these two things. I can have pipelines, which are sort of like a configuration, and the data thing. And then this is kind of an example of raw results coming back, and storing them away. And it actually looks much more JSON-y than this. This is kind of conceptual, but what I saw this morning was much closer. And of course, you download it and you crunch it. This is kind of a list of where ChatBS is, and I've described all of these different features, and you see these are all like, if you kind of think of ChatBS as kind of an engine, a lot of what we need for experiments are here. Okay, but the problem is the experiment management stuff, and that's where the next gen stuff comes in. Is how do we do, how do we organize the overall flow of it, and how do we, if to the extent possible, leverage things like LLMs for grabbing stuff out and ultimately creating the pretty thing. And this is a little bit more detail, and I won't go into this in detail, but you kind of see this. I've talked through all of this whole idea that there's kind of architecturally a handoff from to these different levels. And I think, and this is sort of the kind of a crude, I guess this is a good place to stop. This is kind of a crude place to talk about how we actually do the evaluation. This is very, very specific. For this experiment, we were pulling out ingredients. So there's a bit of code which is doing the ingredient extractor. They are generalizing that to be whatever you're trying to extract from the result extractor. Maybe it's a mineral composition extractor. Maybe you're asking the LLM to tell you about some earth sciencey kinds of things, and you're pulling it out. And so you need the you've got code that is going to do that, and then that's got to be appropriately fed into some query that you've figured out that's going to go off and hit your RDF database. So with that, I'll hand it back to Idaho.
Thanks a lot, John. Yeah, we do have a lot of time for not a lot of time, but we do have time for questions and comments. I see John pasted a question here. John, are you still here? Maybe you can ask it by yourself.
Is it me?
Sure, I can ask that if you'd like. A question that comes up about LLMs generally is sorry, getting some feedback.
Oh, it's probably me. Let me mute while you ask the question.
Thanks. Is there energy costs? And in this case, I'm thinking of it as a indicator of how the pipeline is expansive, and obviously could scale as a function of the multipliers involved. How many patients, how many tests, how many questions for each test, the repeats of each test. Have you given any thought to putting metrics on those costs of how expensive it is for each stage of this process?
So, John, that's a great question because everybody's talking about the energy costs of the LLMs. Most of the environmental impact is on the LLM, on the model construction side. So we're just users of the model. We're not actually, for this work, creating the models, and it's fairly inexpensive to utilize the model to do the essentially the prediction of the model once it's created. It's extraordinarily biblically expensive to create these new models, but it is in terms of the actual construction, it's utilization of these models in the way we're doing is, as far as we know, it's low impact. And certainly the charge, we have a paid OpenAI account, and the costs for I think it probably costs like $5 to do all the experimenting we did as in our final run before the paper was put to bed last like November, December. So
I see a hand rise from Gary.
Yes, John, nice to be in touch again. I have a question on the validation part of this. I think there's a lot of things over there that might be interesting. But in your nutrition example, for example, you had listings of fruit, and then you had bananas, many types of fruit. And this is something that common sense would sort of understand as an issue with any recommendation. So if there's fruit going to be listed as a recommendation, they would give examples of maybe size, because some things have more glycemic indexes than others. And so I'm just wondering whether you've given any thought to adding some reasoning ability over in the validator side.
So no and yes and no. Yes and no. So other people in our group have been involved for several years in the common sense AI stuff, and nobody's brought up explainability. That's a whole nother thing. I don't want to go there right now. But so I think your point is, it's not just about identification of the ingredient. It's also potentially the size of it. It's also about where I thought you were going is unfolding. If the recommendations was only fruit, what do you mean by that? And is that a valid thing? And that was probably not found in Food KG, because why would you have just fruit? Could you be more specific? We probably could have tweaked our queries to be more specific, because it wouldn't. So up front, there's possible ways that you could avoid getting an answer like fruit, or on the back end side, maybe in your maybe there's some sort of thing we could do to categorize.
I think the point here is that there's going to be many concepts that are vague enough, and in many ways that one needs more processing, more common sense reasoning about to be helpful in some areas.
Right. And for the purposes of this experiment, I think it wasn't necessary to go into that. It's sort of like one would want to iterate further on this sort of framework to if that was important. Our next, one of our things we're doing right now is right now we've got an N of 1 as far as the kgs we've tested. There's other kgs that we want to test, like that we've got a really rich data set based on NHANES, our knowledge graph base and NHANES, which is the big health survey. But you need, in order to say that this is a framework which is viable, we obviously have to conduct analogous experiments with different kinds of questions against in a different domain with a different kg or kgs backing that we hit, and kind of test our ability to, how hard is it to generate those Sparkle queries, for example? How hard is it to pull out the specific results? We're going to have to, so I don't know if that, I'm totally avoiding your question, Gary.
Yeah.
Other questions out there? I know we're running long.
Yeah, we may have time for one last question. Anyone?
We still have.
It's going to be open source. Is it going to be open source? Are you going to create a collaboration where people can start adding to it?
Well, there's two different questions. Okay. Okay. So as far as open source in the sense of making it available, yes. Well, two things. We will eventually make the code available. We just have to sanitize and make sure we're not giving away the crown jewels at all. Crown jewels being my API key. In terms of making the service available, we expect to make it the actual application available as soon as it doesn't break. We put ChatBS up as quickly as we could possibly do that in the spring of 2023, just because we wanted people to have the ability to test GPT in a way other than what ChatGPT was. A lot of people wanted to play with large language models, and for a while, the only real thing that was easily available was ChatGPT, and you've got no idea what they're doing beyond the API. So we wanted to give we stood up ChatBS as a way to run experiments in a more friendly way, not having to go through GPT, but also not having to code it yourself, either in R or Python. So yeah, eventually it's going to be available.
Okay. Thanks a
And
lot.
I should,
yeah, John, continue.
I'm just looking to see if so Enrique stayed on. Did Vladimir stay on? No, it was just Enrique staying on. All right. All right. So thank you very much. Oh, she is there. Okay. I'm sorry. I didn't. Yeah. There's Lottie. Enrique, why don't you wave too? Come on. You got to wave. Come off mute and wave at the crowd. Come on. There he is. There's Enrique up in the corner.
Yeah, in the chat box, I also paste the link to the paper John mentioned in his presentation. So anyone, if you have an interest to know a little bit more technical details of the architecture mentioned by John, you can go to that paper. I think it's open access.
Yeah.
Yeah, that Journal Web Semantics, you should be able to access that. No problem.
Good.
Okay.
Yeah, thanks again, John, for your time and this wonderful talk. Yeah, and thanks everyone for your time.
Yeah, thank you all for your attention and your good questions. And
Good.
Have a great day.
Yeah, thanks everyone. Bye bye. Wei Ling, you can stop recording.